Okay, friends, see, in climatology, one of the important topics is pressure belts, planetary winds. But before we understand that, we should have slight knowledge on what is pressure, what is wind, which was discussed with some of the students previously. However, before I start pressure belts, I'll take some 3-4 minutes time to revise the basic concepts, and then we will go into today's topic. Okay. See, in geography, presently, I am dealing with the topic called climatology. Climate, study of climate is called climatology. Okay, study of climate. Climate includes everything. For example, the winds, formation of clouds, precipitation, rainfall, snowfall, cyclones, everything comes under climatology. So, before getting to this topic, I would love to tell you what the meaning of pressure. Some of you know it, but still a small revision. What is pressure? Friends, pressure in physics means force. Friends, see, pressure in physics, it means force per area. But here in this case, force is nothing but the weight. For example, if you keep one can, some water can, any can, what is the pressure acting on the ground surface? The pressure, for example, let us say this is a can. The weight of the can is, say, some 20 newtons. What is the weight of the can? Okay. Now, you know the difference between mass and weight now. Mass is different. Mass is in kg. Weight is mass into gravity. I'm talking about weight here, weight. So let us say weight is 20 Newton. This weight is acting over some area, some 30 centimeters square something. Now what is the pressure what is the pressure in this area? Pressure is the force per area. Here the force is weight per area, whatever area, 30 centimeters square something. Understand? It's pressure. Now in geography, in climatology, we discuss about atmospheric pressure. Pressure created because of atmosphere. Okay? So same, take this earth. At this place, for example, take an area of take 1 centimeter square area. In this area, what is the pressure acted by atmosphere? Here we haven't kept any can, nothing. Just air, atmosphere. See, this is all atmosphere. Atmosphere is nothing but mechanical admixture, means mechanical mixture of some gases, nitrogen, oxygen, carbon dioxide, along with some dust particles, clouds, whatever, some small water droplets. Atmosphere contains all these things. So you have to take only the atmosphere above this place. I want the pressure at this place. So what I'm doing, I'll take atmosphere at this place. This atmosphere, that means air, the air has some weight. Air also is matter only, it has some weight. That weight is acting on this place. How much weight? The weight of atmosphere, weight of atmosphere. So atmospheric pressure is nothing but the weight of column of atmosphere. No need to find weight of entire atmosphere. We will find weight of atmosphere in that column. Only. Okay? So weight of air column divided by area of this place. 1 unit area is called atmospheric pressure. You understood? The pressure. Next thing is another small concept which some of you might have heard in the previous class is pressure depends upon temperature. That means if temperature is increased, again here there are two concepts. If you take a closed vessel, and you take a open place. In a closed vessel, you heat the vessel. When you heat the vessel, temperature increases. When temperature increases, the molecules of gas which are inside the vessel, they get the heat energy. As they get the heat energy, they start moving. They get kinetic energy. They start moving. As they start moving so much, they increase the pressure inside the vessel. If you heat the vessel so much, the pressure of the gas becomes so much that they blast the vessel, they go out. So, as temperature increases, pressure also increases in a closed vessel. But in the open place, in open place, as you increase temperature, here you cannot put the fire. In open place, sunrise. As sunrise fall on the earth becomes hot. As sunrays fall on the earth absorbs the sunrays, earth becomes hot. As earth becomes hot, the air molecules which are touching the earth, they also become hot. Now you will take two places, a hot place on the earth and a cold place on the earth, atmosphere. Now the atmosphere which is in the cool place, the atmosphere also becomes cool. And cool, when the molecules are cool, they do not move much. They stay there only. So, more air molecules stay there. Whereas, in the hot place, the molecules get the heat energy. They become hot. So, they will expand. So, here only a few molecules will be there. Because of the heat, the molecules, means the gas expands, the air goes away. Because hot air is lightweight, it expands. Hence, when it is very hot, as molecules move away, very few molecules are there here, see, very few molecules. In the cold place, more molecules are there, more. Because in the cold place, the air is also cool. Cool air does not move. It stands there only, cool air. Understand? Tell me, where the pressure is more? More molecules, no. More molecules, more weight, higher weight. So, pressure is more here. Here, less molecules, less weight. So, low pressure. So, here in the open atmosphere, as temperature is more, pressure is less. If temperature is less, pressure is more. Opposite relation. So, I would say pressure is, see, in open place, pressure is inversely proportional to temperature. You know this relation, no, in mathematics studied. As temperature increases, pressure decreases. As temperature decreases, pressure increases in the open atmosphere. But in the closed atmosphere, pressure is directly from temperature. As you increase temperature, pressure also increases. As you decrease temperature, pressure decreases. This is second basic concept. I'll tell 3 or 4 basic concepts, then we'll move on to today's topic of pressure belts, winds. Before getting into that, I'm just touching some basic things, that's all. I'll finish in 2-3 minutes, okay? The first basic concept is, what is pressure? And then what is atmospheric pressure, okay? Generally, pressure is measured in bar. The unit is bar. For example, mass is kg, distance kilometers, like the pressure is bar. On the earth, pressure changes. Pressure is not same everywhere, but average, generally pressure is 1013 bar. General pressure near the sea level. On the earth, near sea level, general pressure is 1013. But it changes. For example, what is temperature of the earth means I cannot say. Polar area minus 40, 50, equator 30, 40. Average temperature of earth can be around 18 degrees, 17 degrees like that. It changes, that also changes based on seasons. Like that pressure average 1 to 13 bar, generally, okay? Now, do you know how you measure the atmospheric pressure? Generally, you measure atmospheric pressure in this way. How? You take a U-shaped tube having mercury, okay? Now, you keep it open. When you keep it open, what happens? Here also atmospheric pressure is there, here also atmospheric pressure is there. So pressure is same. Hence, the level will be same. See, same level, here. But one side, if you close one side, close the vessel on one side, air, atmosphere cannot act. Other side, atmosphere acts. So what happens? The mercury will move this side. Slightly increases. So see, here level is different, here level is different. See, the extra level, the extra height is created because of atmospheric pressure only. That's why they also say atmospheric pressure is 76 centimeters of mercury measurement. How many centimeters? If more atmospheric pressure means 78 centimeters, 80 centimeters, like that. Understand? You understood? The pressure of atmosphere is measured using mercury in this way. Okay? Anyhow, I think you are very clear about what is atmospheric pressure. Very clear? Now, I think you are very clear about in geography on the earth, wherever temperature is high, pressure will be low. Wherever temperature is very less, pressure is high. That also understood now. The idea you understood now. Okay. Then the next concept you should understand is, that also I discussed earlier, but for the new students, what is wind? Wind is nothing but flow of air. Flow of air. See, it's called air, but I have a habit of calling it as air. Airport, I call it airport. Okay. Now, friends, see, flow of air. Now, I generally give same example to explain you the meaning of wind. That is water. For example, if you take a plane, pour some water, the water does not move. But if you take a slope and pour water, water moves. Water moves from higher altitude to lower altitude like this. Similarly, generally, this air does not move. This is all air in the room, does not move. But if there is high pressure at some place, high pressure, and low pressure somewhere, then air moves from high pressure to low pressure. So air always moves from high pressure to low pressure. The moving air is called wind. Moving water is called drainage. See, drainage is moving water. Draining water. Drainage is a moving water. Wind is the moving air. If the air is not moving, you cannot call it as a wind. It is air only. Still air, that's all. Okay? If water is not moving, just water is not moving, you cannot call it as drainage. Draining means moving water. Understand? So I think you understood the meaning of wind and how wind is generated. How wind is generated? When there is pressure difference. For example, if pressure is same everywhere, will there be wind? No. For example, if there is a plain surface, will the water move or water stay there only? Stay. Example, lake, water stays there only. River, water moves. Because in river, the base of it is like this. From Himalaya to ocean. Hence river water moves. Lake is like this. Lake water does not move. Understand? So water moves on slope. Similarly, if the pressure is same, wind won't occur. Wind won't start. But when pressures are different, wind starts. Understand? Any doubt till here? So wind blows from high pressure to low pressure. Now friends, after understanding this, now let us come to today's topic. Today's topic is pressure belts. Today's topic is pressure belts. The previous things are just a basic, but I hope you understood. See, if you don't understand such kind of basic things, then you have to by heart pressure belts. I know students who by heart pressure belts because they don't understand the concept of wind, pressure, the concept of temperature, they won't understand. That's the problem. If you don't understand them, you have to by heart everything in the book. I suggest you not do that. So if you have doubt, raise your hands now only. If you have any doubt, raise your hands now only. Okay, friends, now coming to the topic of pressure belts. Belt. I am wearing a belt. See, this is also belt, but this is not pressure belt. This is leather belt. Okay, belt means anything that is less width, more length is called belt. Circular thing. Belt is circular thing. This earth. See, earth is like this earth. So pressure belt is also around the pressure belt. That's why we are calling it as a belt. For example, if this is earth, along the equator. See, on the board I am drawing like a circle, but earth is a globe, earth is a sphere. Along the equator, like this, there is a low pressure belt. Means low pressure. There is low pressure around the equator, low pressure belt. Again, some places, high pressure belt. You understood why we call belt? Belt. What are belt shops? Where we purchase belts are belt shops, right? Okay, anyhow. Friends, see, now coming to pressure belts. Generally, we think that pressure depends only on temperature, but no. Pressure depends on temperature as well as on rotation of earth. Rotation of earth. So pressure is created by temperature as well as by rotation of Earth. Earth rotates. If Earth is stationary, if Earth is not rotating, Earth is stationary, then pressure belts are only by temperature. But Earth is moving, you have to consider temperature and also rotation of Earth, both. If a pressure belt is created because of temperature, if the pressure belt is created because of temperature, we call it as thermally induced pressure belts. Thermally induced pressure belt. Induced. If a pressure belt is created by rotation of Earth, if a pressure belt is created by rotation of Earth, we call it as dynamically induced pressure belt. Dynamically induced pressure belt. So there are broadly two types of pressure belts. Pressure belts which are created because of thermally induced pressure by temperature, and pressure belts which are created by rotation of the Earth. They are dynamically induced. Okay. Now let us move on and try to study different pressure belts. You want to write this one? Dynamically induced pressure belt, thermally induced pressure belt. Okay. Let's go to the pressure belts. Friends, tell me on the globe, along the equator, do we have high temperature, low temperature, friends? High temperature. Along equator, why high temperature, you know? Because, see, if this is Earth, this is sun. Sun rays fall everywhere on the Earth, but sun rays fall perpendicular, like this, perpendicular. More sun rays are on the equator. On the equator, more sun rays fall perpendicularly. That's why more sun rays. See, actually, this is a place. If rays are falling perpendicularly, within less space, more rays fall. If the sun rays are falling slant like this, in this space only one ray is there. If the sun ray is traveling slant, only few rays fall there. Perpendicular, more rays fall there. On equator, they are perpendicular. Hence, on equator, there are more sun rays. Hence, more heat. Hence, equator is hot. Equator is hot. Now tell me, as equator is hot, high temperature, will we have low pressure, high pressure? Very good. So, equator has high temperature, and so now you can draw pressure belt along the equator. Generally, friends, the belt I am wearing may be continuous, but along equator, exactly same pressure cannot be there, no? For example, at some places there is land, at some places there is ocean, at some places there is land. If you take world map, if this is equator, India, Australia, Indonesia, Europe, Russia, South America, North America, Greenland, Iceland. See, along equator, land is there, again ocean. Again land is there, again ocean. You understand? Land, ocean are there. In one of my previous classes, I explained very clearly why in summer season, land is very hot than water. Land is hotter than water in summer. In winter, land is colder than water. That's a separate topic I discussed in previous class. After this class, if anybody has doubt, I will explain separately, but now I cannot spend time on that topic. Okay? There are many reasons for that. Many reasons. For understanding, I can tell one reason. I generally give one example. The example is, you take an empty vessel, you take a vessel with water, you take an empty vessel and a vessel with water, you put both of them on the stove, both, heat them. Which will become hot first? Empty vessel. So this is land. Land is like this. This is water. This is land. This is water. So in summer season, more sun rays are falling. In summer season, more sun rays. That's like fire. When sun rays are there, that means you are putting fire. Then among both land and water, which becomes hot first? Land. So in summer, land becomes hot first. Now come to winter. Winter means less sun rays. That means switch on the stove, switch off, turn off the stove, leave it like that. When you turn off the stove, both become cool now. Tell me which becomes cool faster? Vessel only. water will not become cool faster. It takes a lot of time for the water to, both of them, once you turn off the stove, both of them will slowly release the heat. Release. But vessel releases quickly and becomes cool quickly. Water slowly releases. So in winter season, land becomes cooler. In winter season, land becomes cool faster. It becomes cool faster. Understand? I'm just telling an example. The actual reasons are different, which is separate class. Okay. So now, along the equator, either in summer or in winter, temperatures are not same. In summer, land is very hot than water. In winter, land is very cool than water. So when temperatures are not same, can pressure be same? Why? Why no? Temperature same kaadu. Pressure same hogalda? Avaledu. Ande kada. Why? Because pressure depends on temperature. If temperatures are different, pressures will be different. You understood? If temperatures are different, pressures are different. Hence, along equator, low pressure is there. Low pressure only because of high temperature. But that low pressure is not same, not uniform. So there are few places where pressure is very low. There are few places where pressure is very low. Generally, they identified that very low pressure is there in few places. One of the places, this place, very low pressure. This place, this place. Of course, throughout the equator, low pressure is there. But specifically, very low pressure is there in these places. That's why I marked them in red. Very low pressure. Understand? But while drawing diagrams in the exam or in the textbooks also, they don't draw all these things. They simply draw. Which color do you want? Do you want red or black for pressure belt? Huh? No, blue is better. Friends, see. Here I am drawing the pressure belt like this. In reality, it won't be continuous. I told you no, pressure belts are not continuous. But in textbooks and the exam, we draw like that, that's all. So that it will be simple to understand. Okay. Now, this is from 5 degrees south to 5 degrees north. 5 south, 5 north. This much thick. This much? No, it depends on the size of the earth. Okay, anyhow. So, this is called equatorial low pressure belt. Very good. Equatorial low pressure belt. Okay? You can write down. Till now, you don't write anything, no? Now you can write. Did you write this one? Did you write this thing? Okay, then you draw this one, equatorial low pressure belt, right? Equator, because of high temperature, the low pressure belt. And suggestion is, draw this diagram. In this diagram, you should write that the equatorial low pressure belt is not continuous. It is not continuous. It is more focused on few regions, and draw this map. The low pressure belt is not continuous. It is more focused in few regions. Write like that and draw the map. The low pressure belt is not continuous. Not continuous because of, hello? Akkada na voice kinipistunda? Board rasam kanipistunda? Okay then. The equatorial low pressure belt is not continuous because the temperature of the land and water is not uniform. The temperature of land and water is not uniform. Full stop. Specific regions where low pressure is focused can be seen below. Specific regions where low pressure is focused can be seen in the below map. Shall I slow down or is it okay? If you have to slow down, raise your hand. If you raise your hand, I can tell you that I will not slow down. You have to pick up the speed. That also I can tell, okay? Okay. Okay. Now, this is low pressure belt. Similarly, friends, tell me in the polar area, this North Pole, South Pole, polar area, tell me, is temperature very less or very high in polar area? Very less temperature, very cold. So pressure will be very good, high pressure. So this is called polar high pressure zone, polar high pressure belt. See, belt because in the this earth, no, in the polar also it's like a belt. Low pressure is like a belt. Polar also, okay. So this is high pressure, polar high pressure. This is also thermally induced only, this one also. Because in polar area, it's very cold. Very cold means what? Temperature is very low temperature. Hence, high pressure. Because of low temperature, high pressure. That means it is thermally induced or dynamically induced? Thermally. Because of temperature only it is created, no? Thermal induced. So there are only 3 thermal induced belts. Equatorial low pressure belt, polar high pressure belts. These 3 are thermally induced because temperature, okay? Friends, if, write down something. If earth is, actually it's earth, but I call earth, okay? Friends, see, earth, if it is not rotating, if earth is actually, earth rotates like this. I am earth, I am rotating, okay? Now if I am not rotating, if I am still, earth is not still, then you will have only 3 pressure belts. Polar pressure belts, equatorial pressure belts, that's all. Only 3 will be there. But because earth is rotating, because of the dynamics rotation of earth, because of that, 2 more pressure belts are created. Because of rotation of the, write down. If earth is not rotating, then there would be only 3 pressure belts shown in the there would be 3 pressure belts on equator and polar areas. If earth is not rotating, there would be only 3 pressure belts. That is equator and polar areas, which are thermally induced. Okay, full stop. But because of rotation of the earth, 4 more pressure belts are created. 4 more pressure belts are created, which are dynamically induced. Dynamically induced. Full stop. They are subtropical high pressure belts, and subpolar low pressure belts. Subtropical high pressure belts and subpolar low pressure belts. I'll explain them. See, friends, subtropical area means, actually before that you should understand the meaning of tropical. What is tropical? Only then you can understand subtropical. See, tropical means, if this is earth, this is equator. Equator is 0 degrees latitude. And latitude start from here, 1 degree, 2, 3, 4 till 90 degree north. South also, latitude 1, 2, 3, 4, still 90 degree south. These are the latitudes on the earth, latitudes. Now, 23.5 degrees north is called Tropic of Cancer. 23.5 degrees south is called Tropic of Capricorn. Tropical area means area between the tropics. Tropics means Tropic of Cancer and Tropic Capricorn. The area between these two lines, two latitudes, not lines, latitudes, is called as tropical region. Now what is subtropical region? Subtropical means above this area, above the tropics, this one and this one. It's called subtropical. Subtropical means outside the tropical region. What is subtropical? Outside the tropical. Outside. From 23.5 to 40. Roughly you can say 23.5 to 40. Till 40 is called subtropical. Both north side, south side. 23.5 to 40 is called subtropical. That means outside the tropical. You can write down if you want. Okay. Similarly, what are polar regions? Some 66 to 90. If this is 66 to 90. Here also. 66 degrees south to 90. Polar. This polar region. This is called polar region. 66 or you can say 70 simply. 70 to 90. 7 to 90 is called polar region. That's called polar. Now what is subpolar? Outside the polar. Suppose this one. Outside the polar. Here and here. Outside. That means 60 to 70. 60 to 70 is there? No. Both north and south. 60 is called what? It's called as subpolar. Why it is called subpolar? Outside the polar, adjoining the polar, near to polar is called subpolar. Understand? So you understood the meaning of polar region? Polar. Subpolar region understood? Subpolar. Okay. Tropical, you understood? Tropical. Subtropical, understood? No. You should know these names. Broadly, you should know. Polar means 70 to 90. Subpolar 60 to 70. Near that, over. Tropical means 23.5, 23.5. Tropical. Subtropical means 23.5 to 40. Subtropical. Like that you should know. The latitude number should be known, roughly. The meaning also you should know. You should not buy anything. Don't buy anything, friends. You should have clarity. What is equatorial region? Equatorial. 5 degrees north to 5 degrees south. Exactly equator. Just 5. It's called equatorial region. Tropical region is bigger. Equatorial means only 5 to 5. Tropical means 20-23. Tropical. Understand? Okay. Now you understood that no. Now I will come to this one. Okay. Friends, you have exactly in the subtropical. Subtropical means 30 to 35. Here also exactly, 30 degrees south to 35 degrees south. Here north. You have subtropical region. This subtropical region has high pressure. This is high pressure. Subtropical high pressure. Normally, if you think logically, tell me at 30 degrees, do you have high temperature, low temperature generally? High temperature only, near to equator only, no? Tropical, near to tropical, no? High temperature. Generally speaking, 30 to 35, high temperature will be there, high temperature. High temperature means low pressure, high pressure? Huh? High temperature means pressure will be? Huh? Why are you so dull? Tell your answer louder. Are you doubtful about the answer? Do you have any doubt? High temperature means? Why low pressure? Tell me. See your notes. Did you write? I have drawn air molecules. You did not draw that? I have drawn that? Show me where you have drawn that. Air molecules. No. I explained on the land where temperature is very high, air molecules expand. When it is very cold, air molecules are very close. I have drawn the diagram. Have you drawn the diagram? You haven't drawn? Why you haven't drawn? You should draw. Okay? See? The point is, friends, when I tell something is very basic, it's very important, you have to make a note of that. See, because this basic she missed. Of course, she's a very good student. I know personally she's a very good student. But as she missed this basic, Now she is unable to understand what I am telling. Obviously, if you don't understand this basic, definitely you have to buy heart only. You have to buy heart. From now, you have to buy heart everything. Will you buy heart? Why? You have to buy heart. Because this one you don't remember now. Then how can you understand? You can buy heart, still you can get marks. See, there is no rule that you understand everything. You can buy heart few things. Okay? So you buy heart. Okay? You buy heart, remains you don't buy heart. Because you understood the subject. Okay? Anyhow, friends, the point is, in the subtropical area, generally temperature is high. So naturally pressure should be low pressure. But high pressure is there. Why? Because here, compared to temperature, some other factor is playing very important role. What is other factor? Other factor is? Rotation of the earth only. That's why I call it as dynamically induced pressure belts. Dynamically induced pressure belt means pressure belt which is created because of rotation of earth, not temperature. If it is because of temperature, it should be a low pressure belt. Understood clearly? Next. Subpolar. You take subpolar. You write, I think I told that no, there are 4 pressure belts induced because of rotation of earth. They are subtropical. You should know those things. Okay. Now I am drawing subpolar. Friends, subpolar pressure belt also. Subpolar is also dynamically induced only. It is low pressure. Subpolar low pressure belt. Subpolar low pressure belt. Subpolar means again same 60 to 65. 60 to 65.
Could you please repeat subtropical high pressure?
Subtropical, in subtropical area, generally temperature is high. Because temperature is high, pressure should be low. But here pressure is high. Why? Because of rotation of the earth. Because of rotation of the earth, it is high. But in the mind, because the rotation of the earth, why it is high is the question. That will be answered in the next 5 minutes. I'll tell you why it is high. Okay? But the point is, high pressure belt is created because of rotation of the earth. Similarly, subpolar. Subpolar means near to pole. No, it's very near to polar area. As it near to polar area, it is very cool. Temperature is less temperature. Again, you only. What is your name? Divya. Tell me, here temperature is low. When temperature is low, pressure should be high. Why? Because temperature is low. Very good answer. Okay. As temperature is low, pressure is high. Why? Because temperature is low. Understand? Anyway, I explain it. No, I'll explain it, right? When temperature is very low, low temperature, air is very cool. Cool air is heavy. Weight is more. And weight is more, pressure is more. That is actual logic. Anyhow, leave it. You can by heart it, okay? Now friends, subpolar, generally in subpolar area, temperature is low. So pressure should be high pressure. Pressure should be high. But what I am writing here? Low pressure. That means this is not because temperature. This belt is not created because of temperature. If this belt is created because of temperature, it should be high pressure. This belt is created because of rotation of earth, because of rotation of the earth. Okay. Now here also. So these are the pressure belts. These are the pressure belts. These are the 7 pressure belts. There are 7 pressure belts. But friends, belts are not continuous. I am drawing like this for simplicity. They are not continuous. There are many breaks. Okay. Draw this diagram. And you can write that subtropical and subpolar are not because of temperature. That's all. Subtropical and subpolar pressure belts are not because of temperature. They are because of rotation of the earth. Rotation of the earth. Okay friends, the next point is Now let us try to understand why high pressure, low pressure created. Why? Because rotation of this, what is happening? I'll tell you what is happening. See, now I will draw this. I'll draw this world map differently. Actually, I have drawn it like this. See, I have drawn it like this. Drawn like this. Now I'll draw it like this. Observe for understanding. That will make you understand clearly. I am taking Earth like this, flat, flat. Actually, Earth is not flat, certainly. I am taking this as equator, equator. This as subtropical. This as subpolar. This as polar. You understand what I'm doing, friends? Subtropical, subpolar. This is polar. Subtropical has high pressure belt. Subpolar has low pressure. Polar has equator. Very good. I think now all of you are able to read from what I wrote on the board. Okay, very good. Now see, friends, now, you know, generally in subtropical, the doubt in the mind is subtropical, why pressure is high? The reason is, in subtropical region, which color do you like the most? Red or pink? Huh? Why you like pink color? Any reason for that? But I'll write red only. You know why? I'll tell you the reason for that. Reason. Red is more visible. That's why. I also like pink. Actually, I always wear pink color shirts generally. Okay, friends, now see. So, red color, see. Now, in subtropical high pressure belt, because of rotation of the Earth, there is submergence of the winds. Winds blow like this. Winds blow down. The winds from the upper atmosphere, see, lower atmosphere means what we feel. We are on the Earth, no? The 30-40 meters is lower atmosphere, which we feel. Upper atmosphere means more than 1 kilometer like that, upper atmosphere, which we cannot feel. It is felt by aeroplanes. Aeroplanes which fly, they feel upper atmospheric winds. For example, friends, winds, there are lower atmospheric winds and upper atmospheric winds. For example, upper atmosphere means about 2-3 kilometers, there are winds, but you cannot feel that. You don't even know that. Aeroplanes feel that. When the aeroplanes go, no, they actually feel that wind. Lower atmosphere means which we feel when we are walking Ashok Nagar outside in Hyderabad. Right now we are the center of Ashok Nagar. No? If the wind comes here, we feel it. Aeroplanes don't feel it. Okay? Now, see. So here winds come down. Now tell me, as winds are coming down, will it increase the pressure, decrease the pressure? Increase. Because as wind comes down, lot of air molecules come to the ground. They put pressure on the ground. That's why pressure is more. Understand? This is the reason why subtropical has high pressure. And these winds are coming down because of rotation of the Earth. Similarly, in the subpolar area, the winds rise up because of rotation of the Earth. Here winds rise up. You may get a doubt. Sir, in the polar area also winds can rise up? No, winds can, because actually when the Earth rotates, no, when the Earth rotates, generally in the polar area, there is more chance of winds going up. But they will not. You know why? Because of rotation, winds have to go out in the polar area. But temperature is very less. Polar is very cool. Very heavy wind. That's why they don't rise up. Actually, compared to subpolar, polar only because of rotation of the Earth, compared to subpolar, polar only winds have to rise. They should rise actually. But here, wind is so cool, very heavy, cold, they won't rise. They actually fall down, wind falls down. So, we always should look at dominating factor. What is dominating? There are dominating factors. For example, both have write some answers. Your handwriting is very neat, but content is not good. For her, handwriting is bad, content is good. I'll consider both now. For example, let us say handwriting is very bad, but content is so good, I'll give very good marks only. Something like that. What I'm telling is, we have to see dominating factor. Here, dominating factor is temperature. Equator also, dominating factor is temperature. In polar area, the wind is so heavy that comes down. The wind is so heavy, it comes down, polar area. In equator, temperature is so high. In equator, temperature is high, no, high temperature. When temperature is very high, for example, this is equator, the temperature of the earth is very high, So the air molecules also become very hot, hot air. Hot air is lightweight, heavyweight? Lightweight. So it goes up, no? Rise up, no? That's why along the equator, the wind rises up. Rise up on the equator. Understand? So here wind is rising up because of temperature. Here wind is falling down because of temperature. But in these two places, it's not temperature, it is? Yes. Here also rotation of earth is playing a major role. Here also rotation of earth is playing a major role. There's difference. Understand? Now friends, this side also you can draw same things. You are here on the earth. Aeroplanes are here. You are here. This upper atmosphere, lower atmosphere. This is surface of the earth surface. Okay. I am drawing like this because actually the globe is like this, but for ease I am drawing like this, for ease. I have turned the earth like this. Okay. Now friends, I will use black now. Now observe carefully. Now this point is very important. Observe carefully. As winds come down, for example, do one thing. You take a pipe of water, okay? Floor the plants now. Keep it like this. Does water go till sun, till clouds? No. After going to some height, they have to fall down. How they fall? I have observed. They go like this. Have you seen a fountain? In a fountain, what does a fountain do? At the ground level, fountain pushes the water with force. So water comes up. After coming up, will water fall down like this? No. It spreads out. Why it cannot fall? No. Because already water is coming up. No. How can it fall down? Already pushing up. No. So after coming up, that's why for some questions answer simple. As water goes up, it falls like this. Similarly, as wind is going up from equator, it goes like this. It's called divergence. As wind is going up, wind is also like water only. It has also a weight. Any object having weight cannot escape the gravity. Rockets can escape because they go with escape velocity. What escape velocity? 11.2 kilometers per second. You studied it, no? Escape velocity. Escape velocity is different. But air, just like water, after going to some height, it again, because of gravitational force of earth, it again comes down. Like that. From equator, wind rises up. Divergence, this is called divergence. And it comes down, see, like this, it comes down, like this comes down. You understood? Same here also. Subpolar also, see, like a fountain, subpolar, the wind rises up, after rising up, what happens? It will diverge. Okay? Diverge. Here also. Diverge. And then comes down. After comes down. You have to draw a large diagram, entire book. Otherwise it will become clumsy for you. Board is bigger now. Don't draw small diagrams. Anyhow, you draw now, later on you can try. This is good. That is good. Actually, she is writing notes in the right way. You know how she is writing? The first thing she is doing is, if this is A4 paper, in the paper she is drawing a line like this. And then she is writing the note like this. This is the notes. And again like this. That is the best way of making notes. I told many times to many students that if this is A4 paper and if you write note like this, it's very bad. You should not write like that. If you write like that, what happens? You know, while reading also, you will not move the head, at the eyes. It strains you, strains. If you write like this, you can look at this at once, like this. Over, that's all. Simple reading. That's why see many standard textbooks, they always have, if this is a page in the textbook, there will be gap in between. Observe, gap will be in between. And then there will be matter like this and like this. Write notes like that only. It's better for you to read. Because in UPSC, you have to write a lot of notes, many subjects, You have to write notes such a way that you can read easily. Also, if you write notes like this, a lot of space is wasted. If one sentence ends, entire space waste. Again you have to start. Here, sentence ends also, no space is wasted. The note should be very simple to read and concise. In both ways, it's the best way of writing notes. She's doing that. What is your name? Kiranmai is writing notes very well, actually. Are you a doctor or something like that? Okay. Now, let's come back, friends. Now see, now opposite thing. When the wind comes down with high pressure, when the wind comes down, this is earth. When the wind comes high pressure, falls down, after falling also, will it go into the earth? No, it has to again diverge. As the wind is coming down onto the earth, it diverges. Class lo unnam chesta. Class lo unnam. As the wind comes down, it diverges. Okay. So again here also, see, the wind goes like this. See, like this. Here also, after the wind comes down, it diverges. Here, as the wind comes down, this side diverges, that side there is no earth also diverge. Okay? Diverges. These are the winds. Tell me, first draw it. After that we can tell. First draw. Have drawn it? See, observe carefully, friends. These are called winds. These are winds. See, this is a wind. On the board, maybe it is very small, but in reality, these are planetary winds. They blow across the planet. See, from equator till subtropical. That means, see, where is the world map? Friends. Where is the world map? Yeah. From equator, the winds blow till tropical area, this one. Similarly, here from the winds blow from subtropical area, the winds blow like this. Again here the winds. Actually, the entire earth winds blow, understand? Actually, I'm sorry friends, winds blow like this. Wind blow like this, understand? Winds blow like this. I'll tell you the direction, but the point is, forget about these directions. Remember that I am drawing these winds in a simple way here. Actually, the winds which I am drawing like here, see? These are nothing but from equator, from 0 degrees to 35 degrees, these winds. They cover a lot of the earth. And the wind here, see this wind. The wind covers from 35 degrees to 60 degrees. Entire earth is covering entire earth almost. And these winds cover 60 to 90 degrees. So these three winds, northern hemisphere, these three winds, southern hemisphere, these three winds. This is southern hemisphere. Let us say this is equator to pole, southern hemisphere, northern hemisphere, let us say. There are only three winds. 1, 2, 3 winds in northern hemisphere. South also, 3 winds only. Understand? So, friends, see, in the earth, the winds, for example, the winds which I have drawn here are nothing but from high pressure, winds blow like this. These are the winds. You understood? These are the winds. High pressure to low pressure. If you observe carefully, if you want to remember simply, you can remember that winds always blow from high pressure, see, high pressure to low pressure. See, high pressure to, see here, high pressure to, here, high pressure to. Simple. Similarly, this diagram, what I am drawing here, if it is confusing for you, the actual diagram is here. Winds blow like this. High pressure to low pressure. High pressure to low pressure. I have drawn the black color. These are the winds. This is the same diagram I'm drawing like that for simplicity. Both are same only. But this is a very important topic. Very important for prelims and mains. That's why I'm drawing so many diagrams and explaining so clearly. If you start by hearting this, it's difficult for you to understand. For example, cyclones, air mass, El Nino, La Nina, means other topics which will come later on, depend on this one only. All the planetary winds are very important for UPSC. That's why I'm teaching so slowly. I'm explaining very clearly, and you should understand. You should draw all diagrams. Okay. Now, friends, these are called these winds here. See these winds, these winds, this wind, this one. These winds are called planetary winds. Planetary. Why? You know, because they are blowing across the planet. If I have to give names, these names right now you won't understand. After 5 minutes you'll understand. But the names of the winds are, these two are there, no? These two. These two are called as, what is that? Huh? No, all are planetary winds only. Actually, all are, see, the name of today's class is pressure belts and planetary winds. Pressure belts means these belts, pressure belts, which I discussed very clearly. Now, planetary winds means these winds. Planetary winds, okay? These winds are called trade winds. Trade. Both of them are called trade winds. Tropical winds maybe, but trade winds is the name. I'll tell you why. Later I'll tell you why. These are called westerlies. See, this wind, same here also, this wind, westerlies. This wind is called polar easterlies. I'll tell you, see the meaning will come in next 5 minutes, but these are the winds. So, if somebody asks you, what are the planetary winds? And explain their formation. The question is, what are planetary winds? And explain their formation. Write the question, just generally. Don't write answer now, write answer after go home. What are planetary winds? Question mark. Explain their formation. Write the answer after the class. So what are the planetary winds, friends? Trade winds, then westerlies, and then polar. Only these are called planetary winds. Why they are called planetary? Because they are blowing throughout the planet. This is a planet, Earth is a planet, Earth. Throughout the Earth they are flowing now. Entire planet. That's why called planetary winds. And how they are formed? They are formed because of pressure belts only. These winds are formed because of pressure belts. They blow from high pressure belt to low pressure belt, that's all. What is a wind? Wind is movement of air from high pressure to low pressure. If somebody asks you, why is wind flowing? You have to tell, pressure the difference is there, that's why winds are flowing. Why pressure difference is there? Different topic. That all explain. Pressure belts. Why equatorial low pressure belt is formed? Why subtropical high pressure belt is formed? Different topic. I'll explain that. Why belts are formed. Because of the low pressure, high pressure belts, winds are blowing. If pressure belts are not there, if pressure is same, why will winds blow? So tell me, why planetary winds are forming? You tell me. Why planetary winds are forming? You tell me. What is your name? Huh? Pawan. Tell me why planetary winds are formed? Planetary winds. What are planetary winds? Hey, in class లాస్ట్ చెప్పేసానా ఈసారి నుంచి లాస్ట్ చెప్పను నేను నువ్వు లాస్ట్ రాస్తాను చెప్పి ఈసారి నుంచి ఓకేనా ఓకే యూ టెల్ మీ వాట్ ఇస్ యువర్ నేమ్ గౌతమ్ వాట్ ఆర్ ప్లానెటరీ విండ్స్ దట్స్ ఆల్ winds which blow throughout the planet. Tell me names of planetary winds. Tell me some 5 names. Oh, so 6 7 names. Tell me. There are only 3. Okay. That's all. They are called planetary winds. Not tell me Pawan. What are planetary winds?
Winds which blow throughout the planet.
Very good. You heard from whom? That Gautam. Very good. Name the planetary winds.
Trade winds. Westerlies.
This one you heard from whom? What is your name? So from Kushi you learned something and from Gautam learned something. But from me you don't learn anything, right? అంటే నాకన్నా కూడా వేరే చెప్తే గుర్తుంచుకున్నాం ఓకే ఎనీహో బట్ నేను సి ఇఫ్ దిస్ ఈజ్ సంథింగ్ విచ్ ఐ టోల్డ్ ఓన్లీ వన్స్ దెన్ ఐ విల్ యాక్సెప్ట్ బట్ ఐ టోల్డ్ దిస్ 7 8 times యూ కెనాట్ టెల్ దట్ యూ విల్ నాట్ లిసన్ అది చెప్పకూడదు చాలా తప్పది మీరు చాలా తప్పు చేసావు ఈరోజు ఓకే ఎనీహో లిసన్ కేర్ఫుల్లీ ఫ్రెండ్స్ నౌ ద పాయింట్ ఈజ్ నెక్స్ట్ క్వశ్చన్ హౌ planetary winds are formed? Tell me. First of all, why planetary winds are formed? అప్పుడు రాస్తున్నావు అప్పుడు కూడా కదా వాట్ ఈస్ యువర్ నేమ్ లాస్ట్ బాయ్ వాట్ ఈస్ యువర్ నేమ్ రాఘవేంద్ర టెల్ మీ హౌ planetary winds are formed. They're formed from the board, right? Yes. Planetary winds are created because of pressure belts. Because pressure belts are created. Planetary winds are created because of pressure belts. When there is high pressure belt and low pressure belt, they blow from high to low pressure. That's how they created. What's your name? Huh? Tell me how planetary winds are created. How they're formed. How are planetary winds formed?
Because of the pressure belts.
Yes. Why? Pressure belts are there. Because of pressure belts, why planetary winds are formed?
Because of difference between the pressure.
Pressure. Air flows. That's called wind. When the pressure is different, air flows. That's called wind. That's all. No. Why pressure belts are formed? Hey, why pressure belts are formed? Why pressure belts are formed means because of different pressure. You should not tell like that. Last, what is your name? Okay, you are not even looking at me. Okay, your name. What is your name? Huh? Okay, Chandua. Tell louder. How pressure belts are formed? Tell me. Or why pressure belts are formed? How or why? Different type of temperatures. Huh? You tell me. What is your name?
Avanti.
Avanti. Avanti. Yesterday also I heard Avanti from other classroom. Okay, you tell me, maybe this name is there every class, common name. Tell me,
Temperature.
how pressure, first I ask question, okay? See, always remember friends, never answer before question is asked, okay? Because I will change question to you. See, the question is, how pressure belts are formed? Pressure belts.
Because of temperature and rotating of the.
That's all, that is the answer, very good answer. Pressure belts are created because of temperature and rotation of earth. Because of temperature, which pressure belts are formed?
Dynamically and
Because of temperature, which pressure belts are formed?
thermally induced.
Yeah, what are they? Tell me, name some pressure belts that are formed because of temperature. You should not see the notes. See, if I told 40 points, you can see. I told only 2 points. Because of temperature, which pressure is formed? What is your name? Hiranmai. Because of temperature, which pressure belts are formed? Equatorial.
Polar high.
Very good, polar. Or because temperature. Then, because of dynamic rotation of earth, which belts are formed? అంటే రొటేషన్ ఆఫ్ అర్త్ వలన డైనమిక్ రీజన్స్ వలన ఏ ప్రెషర్ బెల్ట్స్ ఫార్మ్ అయ్యాయి?
Subtropical.
సబ్ట్రాపికల్
High pressure.
హై ప్రెషర్ బెల్ట్ అండ్ దెన్
Subtropical.
చెప్దాం అనుకుంటున్నావా? చెప్పుకోవాలి పర్లేదు, చెప్పలేదు నువ్వు కూడా.
Subtropical.
హై ప్రెషర్ బెల్ట్ అండ్ low pressure belts. Subtropic high pressure belt and subpolar low pressure belt are formed because of
Rotation.
rotation of earth. ఓహో, అంటే బేసికల్గా మీకు ఏంటంటే దో ఐ ఎక్స్ప్లెయిన్ యూ కూడా అండర్స్టాండ్ కదా, మళ్ళీ రిపీట్ చేయాలి 3-4 times. అవును, ఎందుకంటే మీకు దీస్ ఆర్ డిఫికల్ట్ టాపిక్స్ బికాస్ దే ఆర్ దేర్ ఇన్ 7th class 8th టెక్స్ట్ బుక్స్ దే ఆర్ దేర్. దిస్ ఆర్ ఎన్సీఆర్టీ బుక్స్ ఓన్లీ. All points may not be there, but idea is NCERT book it is there. Anyway, friends, I am very happy today that most of you are able to answer very well. So congrats all of you. Now I am moving on. Now I am going to discuss about planetary winds in detail. Planetary winds do not blow in straight line. They blow towards left, towards right, east, north, south, west. Directions are different. Let us discuss how. Let us discuss the direction of planetary winds. Okay? Because observe, generally we think that planetary winds blow straight, but no. They blow like this, see. See, I have drawn like this, see. Why? That is the next topic. To understand that, friends, tell me, these planetary winds are felt by us or aeroplanes? Felt by us only. These winds, they are also planetary winds, but they are upper atmospheric winds. Upper atmospheric. They are felt by whom? Aeroplanes. So upper atmospheric and lower, are they of same direction, different opposite directions? Yes, see, they're opposite. If the lower atmosphere is this side, upper atmosphere is this side, see. If upper atmosphere is this side, lower atmosphere is this side. This is a very important point. You should know this. This will help you in many other topics like monsoon winds. In other topics, you'll understand that. Upper atmospheric winds blow in the direction opposite to, write their point. I don't believe you. I feel that you forget every point except the useless points. Okay, write down. Upper atmospheric winds generally blow in the direction opposite to lower atmospheric winds. Upper atmospheric winds generally blow in the direction opposite to lower atmospheric winds. Okay? Friends, now, what is it? Tell me. Parla chip. Direction opposite to low atmospheric winds. Opposite. Otherwise, write in your own language. Upper atmospheric, lower atmospheric winds blow in opposite directions. Write something. The idea is the blow opposite direction, that's all. You can write in your own language. Don't write my language only. Okay? Now friends, now I am going to discuss about the direction of what? Planetary winds. But before going to this, I want to discuss about the continuity of pressure belts. I told you pressure belts are not continuous, no? Can anybody in the class tell me, anybody, you can raise your hand, why pressure belts are not continuous? Raise your hand. No, raise your hand. You should not answer like that. Raise your hand. One, Gautam, Hiranmai, Avanti. You tell me, Hiranmai.
Because temperature of land is different from temperature of
Water. You tell me your answer.
Pressures are different in different places.
Of course, that's why not continuous. But why? See, the question is, the pressure belt is not continuous. Many breaks are there. Why? Of course, what you said is correct. Pressures are not same. Okay, but why? Why pressures are not same? Temperature? Tell me, good only.
Water in some areas in land.
Because of land and water. Along the earth, land and water will be there. At land and water, temperatures are different, no? That's why pressures are different. That's why same pressure will not be there. That's why pressure belts are not continuous. You write down that. Pressure belts are not continuous. Pressure belts are not continuous in the northern hemisphere. Pressure belts are not continuous in northern hemisphere because of more distribution of land and water. More distribution of land and water. However, pressure belts are continuous in southern hemisphere. Pressure belts are continuous in southern hemisphere because of continuous ocean or more presence of ocean. You can say more presence of ocean. If you don't understand, let me explain the example. If you take world map, this is a world map. Africa, Saudi Arabia, India, Europe, okay, Australia, New Zealand, Indonesia, Philippines, South America, North America, Greenland, Iceland. Observe carefully, friends. This is equator, right? Observe carefully. Above equator, see, from this equator, this is polar area, polar. Equator, this is polar area. Southern hemisphere, see, more, water is more? Water. Continuous water only. That's why the pressure belts are most continuous. Particularly, see, this is equatorial pressure belt, which is not continuous. Why? Land, water, like that. That's why this is like this. Like this. Similarly, subpolar, this subpolar, subtropical. Subtropical also not continuous. See? Land, water, that's why like this. Subpolar are not continuous. Why? Water, land like that. So only it's like this. Polar is single only. Polar, I told you no. This earth, polar is single only. Polar has no problem. Polar. But so in the northern hemisphere, the equatorial, subtropical, subpolar, everything has discontinuity. But in the southern hemisphere, subtropical, okay. Subtropical, there is land, water, land is there. So some discontinuity is there. But subpolar is continuous. Subpolar is continuous. Polar also continuous, polar. That's why I told you very clearly, you can draw, if you want you can draw a diagram, it's up to you. I told you, in northern hemisphere, pressure belts are not continuous. Not? In southern hemisphere, they are continuous. Because southern hemisphere, there is more ocean. Northern hemisphere, there is more distribution of land water. Okay? You can draw a diagram if you want. You can draw a diagram. The same diagram, I can draw like this, see. Equator like this, subtropical like this, subpolar like this, again subtropical, but this time like this and like this. This diagram also explain. Equator, subtropical, subpolar, subtropical, you can draw this diagram where southern hemisphere you can draw continuous belt, southern hemisphere. Northern hemisphere there are some centers of pressure. Okay, this is about the distribution of pressure belts. Okay, now let us come to direction of planetary winds. Before explaining the direction of planetary winds, you should understand one fundamental concept called as Coriolis Force, which is a very important topic, Coriolis Force. It comes regularly in Prelims exam. Coriolis Force. What is it, friend? This year, in UPSC Prelims, recent Prelims, last 2 weeks ago, Prelims exam happened, no? Question was there on Coriolis Force also. Okay, anyhow. Coriolis Force, you should listen carefully. I am slightly disappointed with this class because I feel that after explaining also, some of you are unable to answer the questions. That means you are not listening. You are not listening, most of you. Okay? Listen carefully. Coriolis Force is a little technical, conceptual. If you don't understand, there is no point. If you don't understand Coriolis Force, no, direction of planetary winds, you don't understand at all. You're completely confused. Okay, na? Listen carefully. Listen carefully, okay? See, now Coriolis Force means, before Coriolis Force, I should explain one more fundamental basic concept. If you understand that, then Coriolis Force, okay? The fundamental concept is, if you take Earth, what is this? Latitude, 0 latitude, 0. This latitude is, say some 30, this 60, this is 90 latitude, okay? Take a point A on equator, take a point B here, take a point C, here take a point D. Okay? Now listen to the question carefully. Earth, I am Earth. Earth makes one rotation. One rotation means? One rotation. Means revolving, means moving around itself. For example, if this is the axis of the Earth, axis, moving around the axis. Earth moves like this. Rotation. What is revolution? Around the sun. If this is sun, Earth moving around the sun. Understand? For example, this is sun, I am moving around the sun like this. Now, Earth does both. Earth rotates, same time revolves also. Same time, both, it does both. Tell me, rotation of Earth, one rotation happens in how much time? How much time? Nearly almost 24 hours. Almost 24 hours, okay? Little difference will be there. That's why every 4 years, leap year comes now. Why leap year comes once in 4 years, you know? In a year, exact number of days are not 365. Not 65. 365.25, something like that. 0.25 days extra will be there every year. But we cannot say 2.25 days now. In calendar, you cannot say 1.5 days, you cannot say no. So, we say 365 days only. After 4 years, we'll add all that, make it 36. So, nearly 24 hours. Okay? Now, so, in 24 hours, Earth makes one rotation, like this, one rotation. One revolution, how much time? 1 year. 1 year, okay? Now, observe carefully, friends. Point A, again comes back to same place. This is Earth, no? Point A, B, C, D. Earth is moving. Earth is moving. Point A moves like this, again comes back here. Point B also comes back. Everything comes back in rotation. Point A comes back in how much time? 24 hours. Point B, 24. Point C, 24. Point D also same time. But is distance same? Does A cover same distance as D? Who covers more distance? So whose speed is more? A. Speed is more. Don't think that on the earth speed is same for all the points. Rotation may be same for all points. Speed is not same. What is the formula for speed, friends? Very good. How do you know that? Correct actually. Speed is distance traveled by time taken. Now what is speed of A? What is speed of B? What is speed of C? What is speed of D? If you want to understand, distance covered by A. See, by time. Time is 24 hours only. For every point, within 24 hours only we are taking. Within 24 hours, if A is covering 500, some number I am telling, A is covering 500, B will cover 400, C is 300, D 100 only. Means distance is less, but time is same. Hence, whose speed is more? A, highest speed, B, less. D is like that, okay? Now I'll come to an important point that is not required actually. This is not, UPSC is not required, but if you understand that, it is easy for you to understand Coriolis Force. Observe very carefully. Carefully, okay? Wind blows on the earth. Now wind is blowing. For example, I am wind, okay? Earth is moving like this, okay? I want to move from point A. I want to move from here. Let's say here on place is here, the place name is X. One place is there called Y. I start from X. Wind is starting from X. Wind actually, when wind is going, it wants to go to Y. Generally, when wind is going straight, we think it is going to Y, right? But what happens, by the time wind goes here, Y will not be there. Y will be here. Y is moving. Rotation of the earth. Understand? That's why wind never blows like this. Understand? But for example, I'm here. Wind is coming from here to there. By the time wind goes there, the point moves away. So what happens? Wind actually goes to point P. Because by the time wind comes like this, Y goes away, P comes here. Y goes away, P comes here. Do you understand? No. Niku adonada? Niku? కొంచెం అర్థం ఉండదు. అర్థం అయిందా లేదా అంతే. అవునా ఓకే నీకు చెప్పే ఉంటుంది. Yes, very good. For example, the wind is starting from there. Wind is coming here. I am a point on the earth. He is also point on the earth. Do you want to come here? Do you want to become point on the earth? Do you want to become point on the earth or no? Now you just sit there only. For example, somebody come here. Because I'm feeling bored. I want some time person here. Yeah. What is your name? Kavya, come here. Friends, see, I'll tell you carefully. Listen. Now, stand here. She's a point. I am a point on the earth. She's also a point on the earth. Now, is earth rotating or no? Rotating. So, when earth is rotating, move like this, Move. Hey, move. We are moving like this. We are points on the earth. Okay, now go back. Now, the wind is starting from there. Exact opposite. Wind is coming. By the time we move like this, we moved. So wind came to this place. Understand? Actually, wind is starting from there. You will think wind will reach me. But by the time wind comes, earth is moving now. So wind will reach her. Understand? Now please go and sit. Now, thanks to Kavya for becoming a point on the earth. Okay. See now, friends, so by the time wind comes here, another point will come. That's why we can never say wind goes in straight line. Wind has a direction. Now, here speed of earth is, near equator, speed of earth is very high. But here, speed of earth is very less. It changes. Okay. Now, whatever. See, because of these reasons, because of the rotation of the earth, the wind deflects. Wind always deflects. Wind never moves in straight line. Wind always deflects. Now, how does wind deflect? This is explained by somebody called as Ferrel. Ferrel is a scientist who explained very clearly that wind deflects differently in northern hemisphere, southern hemisphere. He said that, write down. Ferrel's law says that in the northern hemisphere, wind deflects towards its right hand side. Wind deflects towards its right hand side. Full stop. In the southern hemisphere, wind deflects towards its left hand side. Towards its left hand side. Full stop. This is called Coriolis effect or deflection effect. This is called Coriolis effect or deflection effect. Full stop. Full stop. This happens because of rotation of the earth. This happens because of rotation of the earth. Because of rotation of the earth. Okay? Full stop. This effect is observed not only on the wind, but also this effect is observed not only on the wind, but also on moving objects like birds, aeroplanes, missiles, etc. Birds, aeroplanes, missiles, etc. Friends, I have a question for you. You know what is atmosphere, right? For example, this is Earth. Atmosphere thing, but the air around the Earth is atmosphere. It's called atmosphere. Okay, air around the atmosphere. Tell me, when Earth is rotating, atmosphere all rotates or no? See, this is Earth, atmosphere. When Earth is rotating, does atmosphere stay like that or it also rotates along with the Earth? No, raise your hands. Everybody can have your own answers. Raise your hands, whoever wants to answer. Raghavendra, what is the answer? Rotates. Are you sure? You, what is your name? What is your name? Divya. The atmosphere does not move, right? Okay. What is your answer? It also moves. Okay. Oh, Divya, I have a question for you. Because Divya said that as Earth is rotating, atmosphere does not rotate. Stays like that only. Now I have a question for you, Divya. Let us say Earth is moving like this, Divya. Like this, okay? Earth is moving like this. Actually, Earth moves like this. But on the board, I am drawing like this, okay? Moving like this. Now, this is USA. This is Japan. This is India. Something randomly, some countries around the Earth. Now, let us say, according to Divya, let us say the atmosphere is not rotating, only Earth is rotating. Now, there is a crow, khaki crow in Hyderabad, India. That crow has gone up in the atmosphere. That crow actually is on the Earth only in a house, but it wants to fly up because it has wings. So it went into atmosphere. It is playing in Ashok Nagar. Okay, the crow has gone up. It's playing here, roaming here, Ashok Nagar. It almost roamed for some 4 or 5 hours. Here only, this Ashok Nagar, Himayat Nagar, that place, all these places. But in that 5 hours, Earth is rotating now. Atmosphere is not rotating. Earth is moving. So what happens? India goes here, Japan comes here. So after playing for 4 or 5 hours, when the crow comes down, from here comes down, where it will be? It will be in Japan. Now, is that an Indian crow, Japan crow? So, if crows can really move like that, next time again when it jumps, next time USA will come. It will go to USA, crow. The actual crow is not moving. It is just jumping up, it is atmosphere playing, but when it is coming down, Earth is moving. Hence, from this example, Divya, what can you tell? Do you still think atmosphere is moving or not moving? Atmosphere is? Yes, rotating, very good. Friends, along with the earth, atmosphere also rotates. For example, this is Hyderabad, showing India. Crow has gone up. As earth is moving, atmosphere also moves. The crow in the atmosphere, no, it also moves along with it. We are also moving. Right now, are you moving or not moving? We're all moving. We're moving very fast. But you don't feel it because you're feeling it from childhood, no? You don't observe it. Okay? So, atmosphere also moves. That's why wind blows atmosphere, no? Wind is blowing atmosphere, no? So, atmosphere also moves. So, when wind is going, when atmosphere also moving, wind deviates, wind deflects. You understood? Wind deflects. Okay? Atmosphere is moving with very high speed. But you don't know that. Why? Because you're also moving. Okay? Now see. Friends, coming back to this Ferrel's law, I told you what is Ferrel's law. Ferrel's law is, if you take Earth in the northern hemisphere, this is northern hemisphere, this is southern hemisphere. In the northern hemisphere, if the wind is any object, not only wind, birds, missiles, anything, when they're moving, they deflect towards their right hand side, not your right hand, their right hand side. That means you should also go with the wind. This is the wind, no, you also go with the wind. What right hand side for you? What right side? This side. So wind deflects like this. Today I am getting a lot of calls. See, similarly, in southern hemisphere, when wind is moving like this, southern hemisphere, wind will move towards its left hand side. For example, if my left hand side means what? My left means this one. I should draw like this. Right? But not my left hand side, its left hand side. That means you have to go with the wind. This is a wind, no? Wind is going down, no? See, you also go down. Now, what is your left hand side? This one, no? Understand? This is called Coriolis effect. By the way, friends, some people call it as, generally in the books also, they write Coriolis Force, but it's not a force. If you want, you can write in the bracket. In bracket, you can write. It can be called as Coriolis Force, but it is not a force. Write down. Some call it as Coriolis Force. Some call it as Coriolis Force, but it is not a force. It is just a deflection. Some call it as Coriolis Force, but it is not a force. It is a deflection. It's not a force, it is a deflection. Okay, friends? Don't think it's a force. Nobody is forcing it. The wind is deflecting, that's all. Wind, missiles, anything. For example, missiles, for example, I want to launch a missile from, for example, friends, see, where's the world map? Where's the world map? I want to launch a missile from India to here Pakistan is there. Just example, we will not launch, just a joke, okay? Now, when you want to launch, you cannot, for example, see, this is India, this is Pakistan, you want to launch a missile, you cannot keep the missile like this. If you keep it like this, what happens, by the time missile goes there, Pakistan won't be, other country will be there. You cannot tell that, sorry, I want to drop on Pakistan, but Pakistan went away, you cannot tell like this. Hence, you have to calculate the Coriolis force. While launching a missile, you want to launch on some Pakistan, you have to calculate the Coriolis force, and accordingly, the Pakistan is there, you have to launch like this. Then, when it goes, it deviates and goes to Pakistan. You might have seen the maps, missiles go like this, like this, like this. Coriolis force is very important. You should know the calculation of Coriolis force. So how do you calculate Coriolis force? I'll tell you calculation, see. Coriolis force depends upon three things. Force means deflection. How much deflection? Deflection can be less deflection, more deflection, even more. How much deflection? It depends upon three factors. First factor is sin theta, whereas theta is the latitude. For example, if you take the Earth at equator, Coriolis for how much? Sin, what is the latitude of the equator? 0. Sin 0, what is sin 0? 0. At polar area, Coriolis force is not 1. See, Coriolis force is proportional to that, that's all. Coriolis force is not equal to, proportional. Exact force I'll tell you, okay? Now, so Coriolis force is highest, write down. Coriolis force is 0 at equator. Write down. Coriolis force is 0 at equator and highest in the polar area. Highest in the poles. Coriolis force is 0 at equator and highest at poles. Full stop. Full stop. It increases, Coriolis force increases from equator towards the poles. Coriolis force increases from equator towards the poles. Coriolis increases from equator towards the poles. Okay? You know, because of that, what happens? One very good example I can tell you. Friends, see, this is India. I am drawing on South India. South India. This is equator. This is equator. This is Tropic of. I am drawing India only. This is Chennai. This is Visakhapatnam. Sorry, this is Chennai. Chennai, Visakhapatnam, Orissa. Bhubaneswar, not Bhubaneswar. Some Orissa port, some part of the port. Okay. Chennai, Vijayawada, some coastal place of Orissa. Coastal place of Orissa. Tell me where cyclone is more powerful. Cyclone means rotation of wind. No. Where cyclones are more powerful? Chennai, Vizag, Orissa. See, if you tell Orissa or Chennai, logical. How can you Vijayawada? Vijayawada center, no. Either that side or this side I tell. Yesterday also some girl in some other class, I don't remember, she told like that only about pressure. Anyhow. So Chennai, Orissa, where there is more Coriolis force? Huh? Who said Chennai? Raise your hand. You said Chennai, no? Do you again want to become point on that or what? Tell me. Tell me. Parla chippu. Friends, why are you thinking so much? I don't understand. I only told you very clearly, Coriolis force increases from equator towards the poles. This is equator. Towards the poles, this side only, no? So from equator as you're going this side, Coriolis force will increase. So highest force is in Orissa, Coriolis force. So cyclone is also high in Orissa only. Why do you think so much? And I'm asking very difficult questions. I don't understand because you are like very focused, listening but not answering anything. Sometimes people don't listen but still they answer. Anyhow, I'm very happy for the answers. Now see, moving. Coriolis force depends upon the latitude. Okay? Second, Coriolis force depends upon the mass of the object. Friend, this is very important. For example, when you launch a small missile or bigger missile, if both of them you are launching in this direction. Small missile deviates less, bigger missile deviates more. Coriolis force is more on heavier objects. Write down. Coriolis force is more on heavier objects. It can be aeroplane, missile, whatever. Coriolis force is more on heavier objects. Third, Coriolis force increases with the velocity of wind. Write down. Coriolis force increases with the velocity of wind. Velocity of wind. Full stop. That means what? Deflection is more on faster winds. If you want to write down. Deflection is more on faster winds than slower winds. Deflection is more on faster winds. If this is fast wind and if this is slow wind deflects little. Fast wind deflects more. Faster wind deflects more. Understand? So Coriolis force increases the velocity of wind. That means deflection is more on faster winds than slower winds. That's a very important point. These 3 points are important. Okay? But here, you should not be confused. I want to tell you one very important point because some people may confuse in this point. So one important point you have to note down, you have to understand, one important point is that Coriolis force will not, listen carefully, Coriolis force will not affect the speed of the wind. Coriolis force will not increase the speed or decrease the speed. Coriolis force will not affect the speed. It will only deflect, that's all. You cannot say that Coriolis force increase the speed of the wind. Coriolis force decrease speed, you cannot say that. Write down, if you want, you can write down. Coriolis force does not affect the speed of the wind. Write down. Coriolis force does not affect the speed of the wind. Full stop. It only affects the direction of wind. It only affects the direction of the wind. Okay friends, I think you understood now. Coriolis was clear to all of you? Still I doubt you. I think some of you will not understand. Anyhow, I am moving to direction of planetary winds. Now the topic is direction of. Are you okay? Shall we discuss direction of planetary winds, friends? Okay. What is this? What is this? Equatorial low pressure belt. What is this? Subtropical. What is this? Subpolar. And this one is polar. Same here also. Subtropical high pressure belt. Subpolar. This is polar. Okay. Now let us draw. See, winds always go from high pressure to low pressure, like this. Here also wind blows from high pressure to actually. But now because of Coriolis force, show in classroom na Hyderabad lo. Urgent na? Friends see. Now this is above, this is northern hemisphere, below southern hemisphere. Tell me, I'll draw all the winds. These winds also, high pressure, low pressure, and this one. Here also, high pressure to low pressure, high pressure. These are planetary winds. I told you no. This is the trade wind, westerlies, polar easterlies. They are planetary winds. I think I discussed no. Now they will not blow straight. They will deviate because of Coriolis force. They will deviate. Now we will discuss about the deviation only. Okay. I should discuss this one also. I'll come to the next, okay? Now, first let us go to northern hemisphere. Let us look at the whole northern hemisphere for clarity. Now, I will ask questions, observe carefully. In northern hemisphere, because of Coriolis force, the deflection is towards right side. Tell me, for this wind, on right hand side, anybody come who wants to contribute? Anyone wants to contribute? Do you want to contribute? Last boy, you want to write? Okay, leave it. I will discuss, okay. Tell me, otherwise all of you in the notebooks write down. Don't write in the actual notes, rough notes, because some of you may write wrongly. In the rough paper, just write down. All these arrows, wind, you have to show, for example, this wind, I may show like this. I may. Or like this, whatever you think is right, show like, for all the wind, show like that, all of you. Quickly, work on that. Everybody should draw that immediately. All northern hemisphere, right hand side. Deflection towards right hand side. All southern hemisphere, left hand side. Okay. Okay, friends, I think you have drawn. Don't take much time. Just 3 arrows or 6 arrows, that's all, right? Now, show it to me. Quickly, I want to see. What is your name? Kushi. Very good. You are completely 100% correct. Show me. What is your name? Kiran, you have spoiled the book. Why do you cut it so many times? Friends, draw slowly, but finish quickly. Finish quickly, okay? Very good. You also draw very well. Then, hey, it's okay. If it's wrong also, I'll tell it's correct only. Don't worry. I see like this. If it's wrong also, I'll say very good. Okay, don't worry. Give it to me. You keep peacock feathers in the book or what? Hey, okay. One of them is very interesting. Subpolar low pressure to polar high pressure. Do you know what you have drawn? I'll tell you. But it's okay, very good. You have done very well. Do you know? See, wind is blowing like this, no? So you have drawn like this. But you have drawn from this point. You have drawn. When wind is going like this, it will not deflect like this, no? You understand? Anyway, it's okay. Other things are very correct. Actually, you have done very well. Now listen carefully, friends. Maybe, but remaining points you have done correct only. Remaining, you are very good. Friends, let me finish it now. First I'll start with trade winds, both trade winds. See, for example, in the northern hemisphere, this is the starting point. Wind actually should move like this. From here, it has to come down like this. But it will deviate to right hand side. So I will also come with the wind. Right hand side, which side? This right hand side. So, goes like this. Understand? Here, the wind, I am talking northern hemisphere. Right hand side. Right hand means, I am going like this. Right hand means, this side. Similar here, again here the same. No to think again. What I have drawn here, same no. Northern hemisphere, right hand side. So like this. Come to southern hemisphere. Southern left hand side. So if you are going with the wind, what left hand side? Left hand side. Here, westerlies. Come down. Left hand means? Understand? Here no to think. Same can apply. Same hemisphere, no? Southern hemisphere, no? Southern. So, now, finally the correct diagram is, see, here the winds blow like this. Here winds blow like this. Here winds blow like this. Here, understand, here, friends, understand? You have to draw this diagram. This diagram don't draw. This is for your understanding. You don't draw this one for understanding. These are the actual winds. These are planetary winds. Now, I always tell one point. You always name somebody from where they are coming, not where they are going. For example, you came from which place? You from which that place I will not tell. Which place you came from? Oh, Vizag and Kurnool. Okay. Let us say you came from Vizag to Hyderabad. I always tell this. Do we call you as a Vizag girl or Hyderabad girl? Vizag, from where you came. Similarly, here, look at these winds. Are they moving from west to east or east to west? West to east. So they are called westerlies. Here also, they are moving from west to, see, west to east. So they are called westerlies. So westerlies are finished. These two are not like these two. I'll tell you one very important direction. See. What is this? East. What is this? This is south. These winds, no? These winds. So tell me, what is this called? This called as? This called as? You know that, no? You know this, no? Okay. Now here, these winds, see, these winds are blowing like this. So they are called as northeast. Very good. Trade. Why trade, you know? Why trade, you know? This is a place where most of the ancient trade, these days ships have powerful engines. They can go any direction. Nobody can stop them these days. Olden days, there are no engines. They had to go by sailing only. While sailing, I have seen sailor puts a big cloth on the top. Do you know why cloth? When wind comes, he goes with the wind. He can use the wind energy. He cannot go opposite to wind. So, when the trade used to happen here, trade between Asia, then between Asian countries and African countries, when trade used to happen, no, they used to follow the winds. Along the winds, they used to go and do trade. That's why they call trade winds. That's the name. That's why the name came. Northeast trade wind. This one, winds are blowing like this, right? So southeast. Here again, winds are coming from east to west. So polar easterlies, polar, because they're coming from east. So wherever they come from, you have to tell that. Polar easterlies, here also polar. Polar easterlies is the name. Okay? Friends, I have discussed the planetary winds and the direction also. I think direction, all of you understood direction, right? No. Tell me where there is more deviation, trade winds or westerlies, more deviation? Very good. Why westerlies? Force is more. At equator 0, as you go away, more Coriolis force. Hence, westerlies are more deviation. Understand? One more thing. For example, here, these places, in northern hemisphere, no, land, water, land, water, land, water. So there is no uniformity. That's why winds are not so powerful. But southern hemisphere, only water. So there is no obstruction. That's why winds go very fast. That's why planetary winds in the southern hemisphere are stronger. Write down. Planetary winds in the southern hemisphere are stronger than northern hemisphere. Planetary winds in the southern hemisphere are stronger than northern hemisphere because of uniformity of water and pressure. Because uniformity of water and hence pressure. Full stop. That's why westerlies in northern hemisphere are called as furious 50s and shrieking 60s. 60s means 50 means 50 degrees south latitude. 60 means 60 degrees south latitude. South latitude, see here 50 degrees 60 latitude. In this latitude, winds are so strong that we call as shrieking, freaking, something like that. Understand? Furious. So very powerful winds. That's why there was a flight called MH360, Malaysian flight, which fell down here. They could not find it. Once it fell down, they could not find where it is also because the winds are so strong, the water is also so strong. There is something called ocean currents, which I will tell you later on. The movement is very fast there. Southern hemisphere movement is very fast. Something falls, you cannot see it. It will break into pieces and disperse. Understand? Anyhow, coming back, friends. You know, these latitudes are there, no? See. See, this altitude, 30 to 35, or actually it is 25 also you can say. 25, 35, this altitude is there, no altitude. On the earth, equator, this one, 25, 35. 25 to 35. The latitude is high pressure, low pressure? Huh? High pressure, no. Subtropical high pressure belt, high pressure. The wind comes down from top. From top it comes down, high pressure. This belt is high pressure belt. This belt high pressure belt, no. Do you know what used to happen in olden days? Olden days, this equator, high pressure belt, when traders, there used to be horse trading, They used to carry horses from one country to another country, trade of horses. When they carry, for example, let us say a trader is going from here to here, trader is going like this, let us say, going. He is carrying some 1,000 horses in the ship. How many horses? 1,000. He is carrying from here, going. When he comes to this place, no, here pressure is very high. Winds come down, pressure is very high. Because of high pressure, ship is there, no? High pressure, ship, what happens? Ship will sink into the water. High pressure. So what they do, they reduce the weight of the ship. Some weight they can reduce. So they used to take some horses, throw it in the ship, sea. Throw the horse in the sea. So ship comes up and used to travel. They used to throw the horse in the sea because of high pressure. That's why this 25 to 35 latitudes are called as horse latitudes. Write down. Write down. 25 degrees to 35 degrees latitudes are called as horse latitudes. Horse. Because of high pressure. High pressure. You can write it if you want. During the horse trade, they used to throw some horses into the sea. Why are you feeling bad? Now it is not happening. It happened a long time back. Now don't feel bad about it, okay? Okay, now friends, see. Also, one more point I will tell you. One interesting point, see. Northeast trade winds and southeast trade winds, both of them converge. See, they converge. After converging, what happens? They will rise up. That I had explained. Right? See, when two winds come like this, they converge and rise up and diverge and come down. Here I'll see, two winds come like this and two winds come like they converge and rise up and diverge. Here convergence, here divergence. Here opposite, Here they converge, come down, diverge. Here this is diverge, this is converge. I think you understand these things, nothing, okay? So, along the equator, along the equatorial low pressure belt, is there convergence, divergence? Convergence. Along the equatorial low pressure belt, there is convergence of which winds? Northeast trade winds and southeast trade. I understand that northeast trade winds and southeast trade winds converge and rise up. That convergence place is called as convergence zone. The place is called as, but it is between the tropic. That's why intertropical convergence zone. You understand, friends? This is Earth. This is the equatorial low pressure belt. There is convergence of northeast trade winds and south. Write down. Along equatorial low pressure belts, the northeast trade winds and southeast trade winds converge and rise up. Converge and rise up. Converge and rise up. Hence, the zone is called intertropical convergence zone. Intertropical convergence zone. Full stop. It's also called as belt of calm. Or doldrums. Belt of calm or doldrums. That means in their place, it's calm, belt of calm. Doldrums means basically depression, low pressure. Equatorial low pressure belt, no, low pressure, doldrum, belt of calm. You know what happens at that place, friends? At that place actually, when the winds combine, no, see, intertropical convergence. The northeast trade wind, southeast converge. When they converge, friends, they rise up. But some winds, when they converge, some winds escapes the convergence. After escaping those winds, some winds only, they blow like this. This is a equatorial pressure belt, no? Some winds blow like this. Most of the winds converge and they go up, but some winds blow towards west. These winds are called equatorial westerlies. Draw this diagram. Write down, along the belt of calm, there is presence of equatorial westerlies. Along the belt of calm, there are equatorial westerlies. You can draw this equatorial westerlies. That means the westerly winds also, but they are very less. It's feeble. They are very feeble winds, normal winds, feeble. Okay, simple winds, not strong winds, feeble winds. Okay. Okay. I think you understood pressure belts, no? Pressure belts, no? Now, friends, I have to tell you one interesting concept called as movement of pressure belts. Friends, this belt is fixed, but I can move like this. I'm moving up. See. Right? Like that, pressure belts also move. Pressure belts are not fixed, they move. But who moves it? I cannot move it. Sun moves it. For example, you take a magnet, put a small screw, you move magnet. What is the screw also? Have you done the experiment? You have to do it today also? When childhood, we used to take paper. Bill of paper, we put a nail, paper, magnet. Like that, when sun moves, no, pressure belts move. Why? Because, friends, point is simple. Equatorial pressure belt is created because of what? Equatorial low pressure belt is created because of temperature coming from whom? Sun. When sun is here, because of sun rays only, it's created. When sun is moving, why this will be here? This will also move. Understand? Gradually, for example, in summer season, sun is here. Winter season, sun is here. Now, movement of the sun, I explained in the previous classes. Now, I will not explain again. Okay? But after the class, if somebody has doubt, you can ask me. Movement of sun, I'll tell you very simply. For those who missed the class, I'll tell you very simply. Movement of the sun, if this is Earth, if this is equator, if this is Tropic of Cancer and Tropic of Capricorn, sun moves only in the tropical region. Sun never goes out of Cancer, never goes out of Capricorn. Within this moves sun. For example, in the month of March, sun is exactly on equator, March. April, sun goes here. May, sun goes here. June, sun is exactly on Cancer, June. July, again sun comes down, July. August comes down. September, sun exactly on equator, September. October, sun comes down. November, sun comes down. December, sun exactly on Capricorn, December. January, sun goes up. February, sun goes up. March, again here. I have written all 12 months. In those 12 months, you have to remember only 4 important months. They are March and September. March, September are called as equinox. Exactly if you want date, the date is March 21st. September 23rd are the dates. Exactly on those days, we call March 21st as vernal equinox. Vernal equinox. September 23rd as autumn. You know what? You know seasons, no? Autumn, spring, you know, no? Autumnal equinox. Equinox means sun is above equator. Sun is exactly above equator. So equal day and equal night. 12 hours day, 12 hours night. Remaining times, exact hours will not be there. 13 hours day, 14 hours will be there. Exactly, sun will not come at 6 a.m., go at 6 p.m. It will not do like that. But during equinox, sun comes 6 a.m., go 6 p.m. That's all. 12 hours from sun will be there. Okay? Anyhow, March and September are important dates. You have to note down. Similarly, June and December are important. Because on June 21st, sun is on Tropic of Cancer. It is called as summer solstice. Summer solstice for northern hemisphere. Or you can call it as winter solstice for southern hemisphere. That means when sun is here, summer season for northern hemisphere. But winter season for southern hemisphere. Friends, remember one thing. April, May, June, July, August, they are summer for north. But for south, winter. You know why sun is here? No, sun is in northern hemisphere. No, sun is in northern hemisphere. So entire northern hemisphere summer season only. But southern hemisphere is winter season. Similarly, October, November, December, January, this time sun is here. At that time, northern hemisphere, India, all those winter season. But Australia, this is their summer season. Understand? So June 21st is summer solstice for northern hemisphere. Winter solstice for, write down. Good to, you cannot remember automatically, write down. Similarly, December 21st is summer solstice for whom? Southern hemisphere. Write down. December 21st is summer solstice. Write down. December 21st is summer solstice for Southern hemisphere. Winter solstice for Northern hemisphere. June. Remember the dates. March, September, June. Remember it. I'll come back and discuss about I have to come back and discuss about movement of sun, and I'll tell you some interesting climates, Mediterranean climates. And then I have to also tell you about subtropical high. How subtropical high creates deserts. If we finish these two, okay, so what are we discussing? I think I was talking about the movement of the sun. Friends, see, the topic is movement of pressure belts. As I told you, the equatorial pressure belt is created, low pressure belt is created because of sun. As sun rays are falling on equator mostly, equator becomes very hot, because of which low pressure belt is created. As sun moves, equator pressure belt also moves. As equatorial low pressure belt moves, everything moves. All belts move, understand? Because every belt is connected to other belts. So all of them move together with the sun. So first I started with explaining how does the sun move. Now as you understood how sun moves, now let's understand how pressure belts move. But let us not take all these months. Let us take only March, September, sun is here. June, sun is here. December, sun is here. Let us take only 3 positions. Okay? Friends, see, for example, instead of globe, I am drawing like this because I want to show you 3 different positions. Normally, equatorial low pressure belt is here normally, and subtropical high pressure belt is here generally. Okay, this one. Similarly, subpolar low pressure belt is here. And then you have polar high pressure belt. These are the normal things. Normal means in the general condition. For example, this is the diagram for March and September. In March and September, when the sun is exactly above equator. So I'll say this is a diagram for March and September diagram. Then I would draw December diagram and then June diagram. As I told you, March and September sun is above equator. June sun is on tropical Cancer. December to Capricorn. Okay. You have subtropical high pressure belt, and then you have subpolar low pressure belt. Then you have polar high pressure. Okay, friends, let us say this is equator. On the Earth, this Earth actually I have to draw Earth like a sphere, but I am just drawing like this. Okay, this is equator. And this is 35 degrees latitude. For example, here I am drawing here. See, this is equator 0. This is 30 to 35. This is 60 degrees 65. This is around some 85, 90, whatever. Same here, 30 latitude, 60 latitude, 90, 85 latitude, polar area. I am writing latitudes here, and in the March and September, equatorial low pressure belt is exactly on equator 0. Subtropical exactly on tropics, everything like that. Now let us come to December. In December, where is sun? Here, around 23.5 here, sun is here. When sun is here, this equatorial belt moves down. See, in March, sun is here. In December, sun is like this. So this moves. So this equatorial low pressure belt, this one comes down. This one, equatorial low pressure belt. Understand? Subtropical also comes down. Subtropical low pressure belt. Subpolar also comes down. But polar will not move. Because see friends, polar is at the end of the earth, right? Polar areas. How can they move away? They cannot. They'll only reduce in size. For example, if this much polar belt is there, in the month of March and September, in the month of June, when sun goes here, it will reduce, that's all. It will reduce in June. In December, it increases, that's all. But polar belt cannot move because it's the end of the earth. How can it move away? Okay. So polar, I will draw the same place. Polar is same, no change. Similarly, these belts also come, everything comes down. Subtropical high comes down. Subpolar low comes down. But polar just increases, that's all. Polar. Understand? Here also, here June. In June, sun is here. So equatorial belt is here, it goes up. Equatorial belt is here. Equatorial low. Subtropical also rises up. Subtropical high. Subpolar also rises up. Subpolar. And polar is same. All belts rise up. This subtropical rises up. Subtropical high. Similarly, subpolar low rises up. This polar becomes bigger, that's all polar. Understood? Now I will draw winds. Now this diagram is just to explain you that pressure belts move along with sun. You can put the heading, pressure belts move along with sun, draw the diagram. Pressure belts move along with sun. After draw pressure belts, now a very interesting thing will come. Just observe, first draw, I'll tell you. This is going to be very interesting topic, Mediterranean climate. I'll explain that. Have drawn, friends? I don't need to write down the names. Names you can write later. Okay. You have drawn only center part till now. How much time will take? She has just drawn lines. Oh, good. Draw quickly, friends. Why are you so confused? Draw some, first draw this, then just draw everything up, draw everything down, that's all. Now winds, regarding the winds, center part I do not want to draw the winds. Okay, winds means what? For example, From equatorial low pressure, see, subtropical high pressure, how does wind come? Like this. Here also, winds, planetary winds. This is the summer season for northern hemisphere. What is June? June is summer for us. December is winter for us. So I'm talking about us. Us means the northern hemisphere. June is summer. December is winter. For southern hemisphere, opposite. But I'm talking about northern hemisphere. Now I want to draw the winds to tell you one very interesting climate. First of all, I think you would have understood that as pressure belts move, winds also move. For example, equal to low pressure, see, these winds, actually these winds, it come here. These winds come here, right? Actually, high to low. The winds also, see, the winds are like this, the winds also move here. As the pressure belts move, winds also move, right there point. As pressure belts move with the sun, planetary winds also move with the sun. As pressure belts move with the sun, planetary winds also move. This is called shifting of winds. As pressure belts move, planetary winds also move. Full stop. This is called shifting of winds. Shifting of winds. Shifting of winds is a very important concept. I'll tell you why. Now, see, these are trade winds. Both are trade winds. This is, what is this? How does it flow? Westerlies. Here polar, like this. Okay. Here also, which winds will flow here? Westerlies. Here also westerlies flow. Here also draw some winds. Space is there, no, draw some winds like this, okay? Like this winds. So there are the winds in the summer season. Normal season, I'm not drawing, you can draw if you want. Because if I draw so many winds, the diagram will be confusing. That's why I'm drawing summer winds and winter winds, okay? Now winter winds. In winter also, same. Subtropical high to equatorial. Here also. Same here. How do they blow here? Here also same. Westerlies, okay? Polar westerlies. Okay? Now, friends, look at the summer winds, winter winds. I am going to tell you an interesting climate called as Mediterranean climate. What is Mediterranean, you know? Actually, friends, Mediterranean means, if you take the world map, see, take the world map, this is called Mediterranean region. Italy, Mediterranean region, Italy, Greece, Switzerland, these countries, southern European countries. The same climate is observed in here also, same climate. Understand? Mediterranean climate means climate that you observe between 30 to 35 degrees latitude. Understand? So what is Mediterranean climate? Mediterranean climate means climate that we observe between 30 to 35 degrees latitudes. North and south also. South also around Australia it happens. Okay? But it's more prominent and clearly visible in European countries only, southern European countries. If you want to get an example of Italy, Greece, these countries you can write. That's why the sea is also called Mediterranean Sea. You know this sea, friends? This sea. What is this sea, anybody? This is Africa. This is Europe. What is the sea between Africa and Europe? What is the sea called as? Mediterranean Sea. I think most of you know what is Mediterranean Sea, right? This is Mediterranean Sea between Africa and Europe. Okay? And this climate is called Mediterranean climate here. Now I am discussing with you about Mediterranean climate only. Now Mediterranean climate, observe carefully. I am talking about Europe. Europe is a north hemisphere, southern hemisphere, north. That's why I have drawn June summer, northern hemisphere, June summer, December winter. Okay, observe carefully, friends. It is here. It is here. This is a place. Exactly, this is a place of Mediterranean, 30-35. Tell me, in this region, in summer season, which winds are blowing? Northeast in summer. So you can write summer. Which winds? Northeast trade winds. Now come to winter. Same look at winter. Come to winter. Which is blowing winter? Westerly is very important. In winter, westerly is flowing. Friends, what I'm telling you is this area. See, again I'm drawing Africa. I'm drawing Europe. This area, Mediterranean climate. In the world, this is a world map. In the world map, this is all land. This is all land. This is all, what is this? Ocean. Which ocean? Atlantic Ocean. Atlantic Ocean. This is Atlantic Ocean. This is all Atlantic. This is all land. Europe, Asia, land. This is Mediterranean region. For Mediterranean, tell me, Mediterranean region, summer season, which winds are blowing? They come from where? These are northeast trade winds. Which season? Coming from land or water? Coming from? When they come from the land, does the wind has moisture? No moisture. No moisture. When there is no moisture, is there rainfall? No rainfall. No rainfall. No rainfall. Okay. Now, the same area, now come to winter. Winter, which winds are flowing? Westerlies come like this. Westerlies. Okay. So, in winter, which winds? Westerlies come from water or land? Come from ocean or land? When they come from ocean, do they carry water? Is there rainfall? Yes, rainfall. Draw this diagram. You have to write season. In summer season, northeast trade winds coming from land, right? No rainfall. Winter season, westerly winds coming from ocean, rainfall. This is very important. Write that. Draw this diagram. Write that. It's a very important point in climatology. Okay. Now, have you drawn this one? Have you written this one? This is also important. You draw this later after the class is over. After the class, you draw. First, you draw this one. This one I have drawn. Now, I will discuss other climate called British Columbian climate. But British Columbia is, you can say, in Canada. For example, see, this is South America, this is North America, this is USA, this is Canada. In Canada, I am taking this part of Canada. This part of Canada has got, the latitude is 60 degrees, 60 degree latitude. It is called British Columbia. British Columbia, 60 degrees. Now let us see 60 degrees here. 60 degrees, here. Now tell me here, friends, tell me here, in summer season, I'm talking about summer. In summer season, which winds are blowing? Which winds? Westerlies. Winter? Polar easterlies. Very good. So, now take British Columbia. In British Columbia, British Columbia. In summer season, which winds? In summer, you have westerlies. Coming from where? Ocean. Will there rainfall? Very good, there is rainfall. In summer. In winter, which winds are flowing? Very good, polar westerlies. Coming from where? Ocean or land? Land. Will there rainfall? No rainfall. Because when the wind comes from land, that wind will not have water. Moisture will not be there. The wind is coming from ocean only, it can bring that moisture and create rainfall. Understand? So this climate, British climate, this is write down. That's what you write down. Okay? Now friends, you can write one statement if you want. Mediterranean climate will have summer dry and winter rain. Mediterranean climate has summer dry and winter rain. Full stop. Mediterranean climate has summer dry and winter rain. Dry means no rainfall, that's all. Summer dry and winter rain, full stop. British Columbian climate has summer rain and winter dry. Summer rain and winter dry. The reason for these climates is shifting of winds. Planetary winds, shifting of planetary winds. Now, there are more climate called monsoon climate, but in monsoon climate, these two are can be simply explained. But monsoon cannot be simply explained. Monsoon has several reasons, several factors as in monsoon. Monsoon we cannot tell so simply. But in this class, I will tell one of the causes of monsoon. But this is not the only cause. Monsoon is a complicated concept, very big concept. So, this explanation also can be given for monsoon climate. But that is not the only explanation, you should keep in mind. Mediterranean climate is the only explanation. British Columbian, only explanation. But monsoon, not the only explanation. But still, I'll tell you one of the points, okay? Monsoon climate means, friends, this is India, okay? In the world map, how India will be? In the world map, India like this, see, Africa, this is India, see, this is India, like this. This is all land. What is this? Land. This is all land. This is all, what is this? India, what happens is, see, monsoon climate is in India. Not only India, many Asian countries have monsoon climate, but I am taking India. India, we experience monsoon climate only, no? Or Mediterranean climate, India? Monsoon, okay. India is at around 23.5, let us say. India is spread around 23.5, okay? Now here, this one, observe this one. This is India. India is here, 23.5. India is here, okay? In India, here, see, this is India, 23.5. In summer, which winds? Sorry, winter. Winter, which winds? Winter, northeast. Summer, southeast, no? Now listen carefully. Here, many concepts are involved. If you get confused, tell me, I'll stop it. I'll tell in another class, okay? Here, many concepts are involved. Observe carefully. This is equator. Here I have to join two different concepts. So observe carefully. India, in winter season, which winds occur? Northeast trade winds occur. Which trade winds? Northeast trade winds. 1 second. Northeast. Oh my God. Northeast trade winds occur in India in winter. Is it from land or ocean? Huh? Very good. Rain, no rain. That's why India winter season no rainfall. Winter means October, November, December, January, February, no rainfall. Come to summer now. Observe here. Summer, which winds? Here, see. Southeast actually, southeast come like this. Right? Here you have to add one more concept, Coriolis Force. Observe carefully. Coriolis Force in southern hemisphere. Southern hemisphere, Coriolis Force moves winds towards left hand side. But after crossing equator, it's northern hemisphere. Which side of the hemisphere? Right, exactly. So they move to the... Very good. See. So... After crossing equator, they move to the right. You understand? They move to the right. That is very important point. You have to write down that southeast trade winds convert into southwest trade winds. After crossing the equator. Write down. In the summer season, southeast trade winds cross the equator and they become southwest trade winds. In summer season, southeast trade winds cross the equator and they become southwest trade winds. Before entering into India. In winter season, summer season. In summer season, southeast trade winds cross the equator and convert into southwest trade winds before entering into India. Now tell me, these southwest trade winds coming from ocean or land?
Ocean.
So they have rain or no rain? That's why India has rain in the May, June, July, summer season. June month rain is there, no? The monsoon climate. One of the reasons for monsoon climate is shifting of pressure belts. Write down. One of the reasons for monsoon climate in India, one of the reasons, I'm telling you again, one of the reasons for monsoon climate in India is shifting of pressure belts. Shifting of winds. Pressure belts and winds both. Shifting of pressure belts and winds. This diagram are you able to draw? So friends, what I have done is, I discussed about shifting of pressure belts, then shifting of winds. Because of shifting of winds, using the concept of shifting of winds, I explained how many climates? Mediterranean, West Coast climate and monsoon climates. Over, okay? Now, I will move on to last concept before I end today's class. What's time? 5:40. I'll need 2 minutes, okay? When I explained you about subtropical high pressure belt, high pressure, I forgot to give one interesting example. You know what is that example? See, you draw Africa, Saudi Arabia, India, Europe, okay? Australia, whatever. and you draw equator. Then you draw South America, North America. Friends, where is subtropical high pressure belt? This is equator. Subtropical high pressure belt is exactly like this. See. Am I right? That's this side. Am I right? Right or wrong? Africa. I have extended the Africa. Okay, because the map is not exactly as per latitudes. I have done a rough map, no? Now, friends, see. In this diagram, in the world map, I haven't drawn the equatorial low pressure belt. I did not draw equatorial. I have drawn only subtropical high pressure belts. Only I have drawn subtropical belts in the map. Tell me, subtropical high pressure belt, does the wind go up or come down? Along the subtropical high pressure belt, is the wind coming down or going up? Coming down. The diagram you can see, friends. Where is diagram? Yeah. Subtropical winds are coming down or going up? Subtropical belt. That's why pressure is there. Because winds are coming down only, high pressure is there. That's why we call it as horse attitudes, throughout the horses. Now tell me, when wind is coming down, in that place, if there is evaporation, can vapor go up? Can vapor go up? No. How can vapor? See, at equator, if evaporation is there, vapor can go up along the winds. But here, when winds are coming down, how can vapor go up? It cannot go up, no. Here also, it cannot go up, no. When water vapor cannot go up, will there be rainfall? For rainfall, vapor have to go up, become cloud, and then rainfall. Hence, there is no rainfall in these areas, subtropical. When there is no rainfall for a long time, what happens? Deserts form. Desert. What is desert? Desert is a place where rainfall is very less. Almost zero. Not zero, but very less. Write down. Along subtropical high pressure belt, as the winds subside down, there is very less chance of water vapor going up. Full stop. And hence, no, full stop. Hence, cloud formation and rainfall are difficult. Cloud formation and rainfall are difficult. Full stop. Hence, most of the deserts in the world are found on the earth at the latitude of 30 to 35 degrees north or south also, same. 30 to 35 degrees north and south. Most of the deserts on the earth are found in the latitudes of 30 to 35. Why 30 to 35? Because this is a subtropical high pressure belt. For example, friends, you can see some of many latitudes. For example, the latitude, for example, many deserts. Here you have Sonoran Desert, in Mexico, USA border. Here, Africa, you have the biggest, what is that? Sahara Desert. And here, Mongolia Desert. Write down, you have to write the map also, Mongolia. In Australia, what is the desert in Australia? The Great Victorian Desert. In South America, this side, what desert you have? Atacama Desert. This side, Patagonia Desert. In Africa, what desert is there here? Kalahari Desert. Even Namib Desert. Both deserts are here. In Africa, Kalahari Desert. Here, Namib Desert. Australia, Victoria Desert. In South America, this side Atacama, that side Patagonia deserts. In USA, Mexico, Sonoran. Africa, Sahara. Asia, Mongolia. See, many deserts are there. All most deserts are in this place only. Why? Because of dry, no rainfall. Why? Winds are subsiding. Understand? Draw the map and write down that. India, na? You can write Thar Desert also, but Thar Desert also around 30 degrees only. 30 degrees only, Thar Desert. Thar Desert is also here only. India map, I have drawn only South India map. If you draw North India map also, Thar Desert also come there only. It's a good point, good point. Thar Desert is also in the subtropical high pressure belt only, Thar Desert. Kalahari, Namibia, Victoria, you should know the names. It's very important from Prelims point of view. Mains also, there was a question, there was that why most of the deserts are in 30 degrees latitude on the west side of continent. But west side of continent, I cannot explain using this one. West side I can explain using ocean currents. We will go to ocean currents class. In ocean currents class, I'll explain. Actually, if you observe, they are West Sea, Sahara, west, mostly west. Australia, west. Africa, west. Mostly west, mostly. Because of one reason, because of cold ocean current. But that, if you want, you can write now. Again, oceanography, you can write. Most of the deserts are on the western side of continent. Most of the deserts are on the western side of continent. Western side of continent. Because of presence of cold ocean currents. Don't worry about this, we'll discuss later in other class, oceanography class. Because of the presence of cold ocean currents that cause desiccating effect. I will explain these things in oceanography, okay? That cause desiccating effect. Okay? Now, friends, observe carefully here. This is the last point. I'll end the class with this one. Observe here. Here, have you observed anything like a cell? See. See, here, see. Cell. You see a cell? This cell means movement of the wind in a circular fashion. Cell, completion of a cell. This cell is found by somebody called as Hadley. That's why it's called Hadley cell. This also. Hadley cell. This cell, look at this cell. Are you able to see this one? Perfect cell. This is found by Ferrel. We call Ferrel cell. This is found by somebody called Ferrel. Hence Ferrel cell. And this cell is called clockwise. This is anti-clockwise. Look at this anti-clockwise. This cell is called polar cell. Polar cell. Okay. So there are three cells: Hadley cell, Ferrel cell, polar cell. You know, there is a common name for this. It's called three cells. Hence tricellular. Three cells means tricellular circulation. షణ్ముఖ్ నేను హైదరాబాద్లో క్లాస్ చెప్తున్నాను క్లాసు. శిరీష కూడా నాకు కంటిన్యూస్గా ఫోన్ చేస్తుంది. అంటే ఒక్క 1 minute వెయిట్ చేయి, క్లాస్ ఫినిష్ చేస్తాను, బయటకు వస్తాను. Tricellular meridional circulation. It's also called as circulation. It's also called as atmospheric circulation because the atmosphere is moving. No, you understand? It's atmospheric. No, not the above the earth, above the land. Atmosphere is moving like this, almost at 2-3 kilometers like this. Winds are coming like this, going up like this. It is going through entire Earth, entire planet. This entire Earth, no. So entire atmosphere is moving. The atmosphere is moving. You understand? They are very interesting cells. Atmospheric tricellular meridional circulation of the wind. Circulation. Friends, actually some more things are there, but I'll discuss later. But broadly, I finished two things. Pressure belts, I finished completely. Nothing can go beyond this. Pressure belts. Planetary winds also finished mostly. I have to discuss only local winds and monsoon climate separately. I should discuss monsoon climate, local winds, Chinook, Foyne, Sirocco, Harmattan, some winds are there. And mountain breeze, valley breeze, sea breeze, some breeze are there. But they're separate topic. I will discuss it next class.